I'm going to work another problem off of the practice problems on the S drive. This is also under gas laws and chemical equations. And I'm going to work problem number 4. And if we look at this reaction, we see we have calcium oxide, sulfur dioxide making calcium sulfite. And this problem asks us for the mass of calcium oxide. So we're interested in this formula. That's going to be B. And we are given information about sulfur dioxide. So we're given information about SO2, that's the gas, which means we don't care about that. We're also given a volume, and we have STP. So this is the case where we're going to use N equals PV divided by RT, and that's going to equal moles of A. We're not going to go from grams to moles. We're going to use the gas law to get to moles. Then we're going to go to moles of B, and then we're going to go to grams of B. So we are not going to do step 1 from grams to moles. And we see that we're given a volume equals 102 milliliters. That's 0.102 liters. STP simply means the temperature is 273 degrees Kelvin and the pressure is 1 atmosphere. So when we solve this problem, when we solve for N is going to equal moles of SO2. Then we're going to go to the balanced equation and calculate moles of calcium oxide and then grams of calcium oxide. So I'm going to plug all this information into the gas law equation. N equals our P is 1 atmosphere, V is 0.102, R 0.0821, and T is 273. When we get this value, this is going to be moles of the gas, SO2. We're still going to go to the balanced equation and convert from moles of SO2 to moles of calcium oxide. And even though this is 1-to-1, 1 mole of SO2 is required to react with 1 mole of calcium oxide. We should still show this balanced equation step. So we referred to that as step 2. Then we're going to get out the periodic table and add 1 calcium to 1 oxygen. So 40 plus 16 is 56.08, and that would be moles of CaO. Oops, nope, that 56 is in the wrong place. Remember, that's grams. So the mole, the big fat 1 mole, goes on the bottom, and the 56.08 grams goes on the top. So the number we get off of the calculator, calcium weighs 40.08, oxygen weighs 16, so that's our molar mass step, step 3. So I'm going to do all of this before I plug these values in. And then we are ready to just go straight through the calculation. 2, we're going to divide that by 0.0821 and divide by 273. And when I do that, I get a pretty small number, 0.00455. I could stop and write that down, which I'll do here. And I'm going to leave that number in the calculator, and then I'm going to multiply by 5608. These ones are not going to change that value. Times 56.08, and when I do that, I get 0.255. So the answer to this calculation is 0.255, and the units that would be left, since those cancel and those cancel, that is going to be grams of calcium oxide. And if we check that answer here, we see that that's correct. So as a quick summary, the only 2 types, well, I'll leave this here for just a minute. The only 2 types of balanced equation problems we're going to be looking at when we are in the gas law chapter. We're going to go from the mass of A to moles of A to moles of B, and that's when B is the gas. Once we have the moles of a gas, which is step 2, we're going to remember that that's N, and we're going to solve for the volume. nRT divided by P. T and P both must be given in the problem in order for us to solve this. So if we're given the mass of a solid, the only thing we can do is go to moles of the solid. Then from the balanced equation, which is step 2, we can go to moles of a gas. Then we could solve for the volume of the gas because the moles of the gas is N. The other shortcut that we would do, the only other case we're going to have, is going from a gas. So we would solve for N, PV over RT. These would all be given. So if we know the pressure and the volume of the temperature, then we could solve for moles of A. In this case, A is going to be the gas. So whatever that number is, we're going to go to the balanced equation and solve for moles of B. And then we're going to use the periodic table and the molar mass and do step 3 and solve for grams of B. So those are the only 2 variations that we're going to do using the stoichiometry map.